All right. So Raz, we are doing a recap again for some topics. Okay. Because Sagar didn't join earlier stage. So we are doing in the English. Okay. Because already we done in the Hindi. So we are trying to do in English. So let me know if you're having any doubt, any like confusion, right? For any concept. Okay. So we discussed very basic thing about the network component, right? What is the router? What is the switch? What is the layer 2 switch? What is the layer 3 switch, right? What is the next generation firewall? What is the access point, right? And also DNS center and endpoints, servers, and power over Ethernet. So a lot of things we have already, like discussed in previous class. Now we just have to understand about the architecture, network topology architecture. So first we have to understand what is a network topology. Then we'll try to understand about the architecture. So if I am asking the topology, so topology is just simple definition, connection of devices, connection between the devices, right? So you having the router, right? Let's see this router. This router is connected with the switch, right? This is switch. Behind this switch, user PC is connected, right? Might be this PC is connected, or be connected one of the access point AP, and behind this multiple mobile users connected or laptop connected via the Wi-Fi, right? This switch is connected with this router. This further router is connected with internet. So we have one diagram here. You can see very small diagram and very basic diagram. Even your home having this diagram. So anything you represent in a diagram, right? Any network connection you represent with the help of diagram, that's known as the topology, right? So if someone is asking what is a topology, network topology just is connection between the devices, right? It could be the routers, right? It could be the switch. It could be the firewall. It could be the servers. It could be the printer. It could be the access point or WLC, CCTV, etc. So a lot of devices we have. So if we are going to connect them together, these are going to build a network topology. Okay. So don't be confused. If you not able to understand, just copy this, right? Just copy this and just go on the Google, right? And always try to just go with the visualization, right? Just go in the visualization. So you'll see these are the network topology architecture. See, so diagrams, right? It's diagram representation to how devices are connected, how we connected the devices between each other. So if we are going to do this way, that is basically known as network topology. It's very straightforward. So if someone is going to ask you, what is a network topology? You have to explain it's like interconnection between the devices through the cables. And we are going to represent through that connection with the diagrams. That's known as the network topology. Okay. So don't be confused. Okay. Now, further, this network topology has been classified in the different way, right? There is a classification. They having a classification for the 2 tiers. We having for the 3 tiers. We having the leaf in the spine, and we having the WAN infrastructure. So we try to understand step by step. So let me just open my CCNP in core, which having the better representations. So I'm going my CCNP in core. Let me see where it is. Okay. So in this CCNP in core, which is going to be your next module, right? So in this CCNP in core, if you're going to check that architecture, okay, network architecture. So in this network architecture, you'll find a lot of diagrams. See, so this is the diagrams. where we are connecting the different devices. So some small, some big, but we having a diagrams. We cannot, run away from diagrams. See, these are the network topology diagram, right? So there is a term, two-tier and three-tier architecture. Two-tier and three-tier architecture, right? So what is a two-tier architecture and what is a three-tier architecture, and what they are going to represent? So whenever I'm going to talk about two-tier, three-tier, or spine and leaf, these all three, you just think about or just focus about first these two, two-tier and three-tier. So in my office, we having a two section. In my office, we having a two section. One we call as a LAN. This is a local area network. And another section we have where we connecting the internet. That area is known as the WAN, which is known as the wide area network, right? So we having a LAN, we having a WAN. These two components we have. So how this LAN is going to connect? So WAN always required another layer 3 device, which is known as a router. And this is going to connect the WAN. So this is known as the WAN connection. WAN connection. But behind the router, we required a switch. This is very small, and this below switch we having a different devices could be connected. This is known as the LAN. You can take this as a LAN connection. So we having a WAN connection, we having a LAN connection. So if I'm going to use two-tier or three-tier, these two-tier and three-tier always refer to LAN topology. Means it is not related to WAN. First thing we just have to be clear. So two-tier, three-tier, and even the leaf in the spine, they all related to the LAN. But this one is more about a data center LAN, DC LAN. And this is more about the campus LAN, means your office's LAN. But this is for the LAN. These all three are the LAN, and this is the WAN. WAN is a different one. So if I'm talking about the two-tier, three-tier architecture, that means we are referring as a LAN. All right. So what is the meaning of two-tier architecture? What is the meaning of two-tier architecture? So now you understand, if I'm talking about the two-tier, that means I'm referring the LAN. And LAN, what connects? Switch. So we are talking about what is a two-tier switching infrastructure. What is two-tier? My LAN infrastructures. This thing we just have to understand. So if I'm going to understand two-tier, so that means in my LAN, I have multiple switches connected in this way. So this is a switch. And behind this switch, what device connected? Endpoint. And what are the endpoints? This could be the computer, this could be the server, this could be the printer, this could be the laptop. So these are the endpoints. PC, laptop, printer, any could be. And these are connected with the switch. Further, these switches could be connected with another switch. This further could be connected with another switch. So might be this connected with this way, this connected with this way, and this connected with this way. But why? Why we done so? Because if this switch is going to be disconnected from this switch for any reason, still they having the redundancy from the another switch. right? If this switch goes down, still this switch is going to provide the network connection because router is going to connect both of the switches. And further, we are having the internet. So either of this switch, any of the switch is going to be down. Either this one is going down, still the network is going to up and working via this way, right? Even this link is going down, my network is keep working via this link. Same condition. If this is going to down, my network is keep going via this way again. So we having a redundancy. So to maintain the redundancy, allocate the equal load within the switching environment, we divide the switch infra in two parts. So first part we known as the distribution layer. Distribution layer. And this part we also known as the access layer. But when we talk about the two-tier architecture, this distribution layer become the core layer. This become the core layer. It is going to act as a core layer. How it's going to look like? Let's see. So if you are going to refer the two-tier architecture having this way connections. Let me show you. See, two-tier architecture, we also know as the collapse core. So we'll understand what is a core, what is a distribution, what is the access layer, but just understand first. When we having just two layers, right? We having a core and distribution, which is connected with the access point. Means access switch, not access point, and that access point is connected with the end users. You can see here. So this is known as your two-tier architecture. Means your core and distribution is just going to become the same layer, and this is the access layer. So now we having a three layer of devices. Let me just write here. So we having a in LAN, we having three layers of devices, right? So first one is, right, what is the first one? First one is your core layer. Second one is distribution layer. And third one is your access layer. So you just have to understand why we use access layer. So access layer basically used to connect, it used to connect endpoints. And what is the endpoints? Like PC, laptop, right? Access point, right? Server, right? Printer, anything, you can connect it. So this is the access layer. So on access layer, your actual PC is going to be connected. So when you sitting in your office and you connected with any of the switch, they always refer as the access layer, and our devices is going to be connected with the access layer. So that is known as the access layer, right? But when we talk about the distribution layer, so distribution layer responsibility to provide the connectivity, it provide the connectivity between core and access layer, right? So it's responsible to provide the connectivity. So it's acting as a man in middle. So see, this is the man in middle. So this is just providing the connectivity to the access layer and the core layer, right? So let me just use some other diagrams so you can understand in this way. Let me just show you this one. See this one. So this is your distribution layer. So this is your distribution layer, we known as a DL. This is your access layer, AS, and this is your core layer, right? CL. You can known as a CL, core layer. So the core layer, what is the core layer? So core layer basically is just responsible to provide connectivity between DL, distribution layer, and WAN router. That's all. WAN or internet. WAN or internet. Anything you can just mention. So this core layer is responsible to provide the connectivity. See this, if you want to go on the internet, you can go via the core layer. See, this is going to via the core layer. You want to go, the core layer is responsible to make this connection happen. So 3-layer, that is the access layer, that is used to connect the endpoints, PC, laptop, access point, WLC, printers, servers. These all are going to connect with the your distribution layer. Your core layer is going to connect with the WAN to the DL, and DL is just bridge to connect between the core and your access point, right? So I hope it is clear to everyone. This is your DL. So now, if I am talking to 3-tier architecture, so that means my company having all 3 layers. If I am talking to 3-tier architecture, that means my company using all 3 layers, exactly all 3 layers. Same they are going to use. But if I am talking to 2-tier architecture, that means my company is just using core and distribution as a 1 layer. So in case of the 2-tier architecture, your core and distribution layer will having a different role and responsibility, because they are responsible to do these 2 stuffs together. So one, they are responsible to make the connectivity with the WAN, and they also responsible to make the connectivity with your access layer, because they both are going to become the core and distribution. So there is no core functionality. So core is just going to terminate. This is a 2-tier architecture. When you are going to use core and distribution together, means you don't want to use a 3rd layer, because might be your office is going to be small. Your branch is very small, no required lot of switching capacity, no more port required, no much routing engine required. So you can use the collapse core. So 2-tier architecture, also known as the collapse core. 3-tier architecture is a 3-tier architecture which having a 3 layers. That's all. Any question in 3-tier architecture and 2-tier architecture, or is it clear to all? Just let me know if anyone having any question, right? So I can get the clarification. So 2 and 3, first thing, they are totally in the switching environment. They are just having a different roles for different layers. And that's roles I just provided here, and they provide the different type of connectivity. Okay. The next one is the leaf and spine. So leaf and spine again going to work as the 2-tier and 3-tier architecture, but they having a different name. So leaf and spine is going to use, there is one technology is known as the ACI. One technology is known as the ACI in data center environment. Data center, right? And this leaf and spine, so ACI is application centric infrastructure, right? So in this application centric infrastructure, ACI is application centric infrastructure, we use spine leaf model instead of 2-tier and 3-tier architecture, right? So I'm just understand architecture, right? So whatever we having a application centric infrastructure, that is the ACI in data center, right? We use the leaf and spine model that is similar to the 2-tier and 3-tier architecture, but name is a leaf and spine. So how they are going to look like? So if you see here, leaf and spine architecture, just go and see. So it is similar to the this, just compare it. So what was happening in the previous stage? This is a traditional 3-tier architecture. In this, you having a core, you having aggregation, you having the access. Aggregation is just a distribution layer. Don't be confused. So if someone is saying aggregation, just understand this distribution. The meaning is going to be same. So aggregation and distribution layer is the same. And if you want to use the same in the data center in the ACI, right? You use this leaf and spine. So leaf and spine, just think we having a one core layer which replace with the spine, right? And we having the access layer which replace the access layer. Also, they are going to work exactly the access layer because your end devices in going to in leaf and spine model, your leaf is going to connect the all end devices. Means your server, your printer, your AP, your WLC, whatever you think, CCTV, everything is going to connect to the leaf. So leaf is exactly similar to the access layer switch, and the spine is similar to the, like you can think about the core layer, or it's a core plus aggregation layer. You can just think about that. Because you're just having a two layers, we're not having a three layer. So leaf and spine always two tier architecture, not three tier architecture, because they're just going to use in the data center environment, and they use a 9K switches, Catalyst 9000 case, 9000 switches. That's known as a 9K switches. They are just designed for the special purpose for the data center, right? So this is a leaf and spine model. So if I'm going to back again in CCNA, so leaf and spine, if you think about the two tier, three tier, all are the same. Only you just have to understand these two can be used in your campus network, right? So what is the campus network? That means the office LAN network, right? And this is for the your DC LAN network. That's only difference, right? But the model is going to same. It's a two tier architecture, and these are the two and three tier architecture. So always go and search this in Google and find such kind of the beautiful diagrams where you can refer it and you can get the clarification from them. Okay. So this is the another story. Next, WAN. So what is a WAN? So if I am talking about the WAN, so WAN, like wide area network. So anything, if I'm talking about the WAN, so you just think any internet cloud might be different region, we having a different cloud. So in US might be having the Sprint. In Canada, we having the Bell Canada, Bell C, right? We in India, we having a Airtel. It might be the UK. We having some kind of the another. Just think about the Verizon. It's again US based, or ATT, right? So these are the different ISP, right? And you want to connect them together, right? You can connect them together. But again, this is going to become the connection of the internets. And they once they connect together, they're known as the internet. So now these are the all internet provider. You are in the US, right? You are in the Canada, right? You are in India, you are in the UK, right? Anywhere. So let's you having the 4 branch offices, right? You having a 1 branch offices here, right? 1 branch offices here, 1 branch offices here, right? 1 branch offices here. So these are the branch offices. So what is inside the branch offices? You having the switch. This is the switch. This one also having a switch. And behind the switch, you sitting, your colleague sitting, right? So behind the switch, your people are sitting. This also having a switch. This 2 people also sitting here. This also having a switch. Just think this is switch. 2 people also sitting here, right? So now this Mr. A want to talk with Mr. B. He is in India. Then how it is going to talk? What is the method he can talk to him, right? So make it possible, we require the wide area network, because inside the office, right, everything is known as the LAN. So LAN just responsible within the office. They are not responsible outside the office. So whatever you can see within the office, they all are referred as a LAN. But if you want to talk to outside the office, you going to require the wide network. So we need another special device that is known as the router. So every location we need to install the router, right? Every location we need a router. Every location, and that they all are going to connect with the ISP. So this is the router, this is the router, this is the router, this is the router, and they all are going to connect with the ISP. So the once we connected this ISP with the router, these are known as the WAN connection. These are the known as the WAN connection. So this is going to all become as the WAN. So now you are know about the LAN. So if this Mr. A want to talk, it is going to on router. Further, router will take the routing decision, and they will come to know how I can reach to this particular Mr. B. So it will go to the WAN, and via the internet cloud, they will come here, and via this router, they will going to talk to him. So they start talking to each other, right? So if they start talking to each other, that is because we having the WAN connection. So WAN is something, it is a larger scale. If you want to communicate with the larger distance people, right, via the air or via the wired, the WAN is responsible to make this happen. If you are in the within the home, within the building, within the campus, the LAN is enough to make the communication happen. Okay, so this is how LAN and WAN is responsible to make the connection end to end, where user can seamless experience the connectivity status, whatever they are going to do. Like they are exchanging some kind of the words via the chats, they are exchanging some kind of the files between these two office, or might be from this to talking to these people, might be from this talking to these people. It can be anything. So this entire collection of the ISP is known as the internet. And once you connect your office through the internet, that's known as the WAN. So this is your wide area network. So if you go on the Google now and try to search WAN, so you'll find this kind of a diagram, what I just explained. So these are the world, right? And this world is known as the internet. This is nothing, this is the internet. Okay. So once you connected every branches, these are the different branches, right? You require the layer 3 devices. Router should be every location, right? And this router is going to connect with the ISP router, ISP router, ISP router, ISP router. And once they all join together again, they form one of the internet. And that's why this PC want to talk with this PC. They will just follow the internet connection, and they will keep going to talk this way. They're going to talk this way. They're going to talk this way. They're going to talk this way. Whatever they are going to think, all communication is possible. Okay. So WAN is nothing. WAN is a wide area network, which is responsible to provide the connection to multiple LAN, which is responsible to provide the connection to the multiple LAN with the different distance of geography. Okay. So this is your WAN. I hope it's clear. So now we understand about the 2-tier architecture, we understand about 3-tier architecture, we understand about the leaf and spine, we understand about the WAN, right? What's next? So we having scenario, small office, home office, small office, home office, which is known as the SOHO. So if you find this word SOHO, SOHO is small, O is office, H is home, and O is again office. So SOHO is small office, first 2 letter, and last 2 letter is the home office, right? So what that mean? What that mean, small office and home office? So let me just go on my slide and try to show you something. See. So these are topology diagrams, which I explain. Same thing in my slide also. So you are in your home and you are doing the internet communication via the Wi-Fi router. Still, it's a network. In your home, what we have in my home, just I have one router, right? Let me just. So just think, this is my one of the router, right? In this router, I have two antennas, right? They keep radiating the signals to entire my bedrooms, drawing hall, whatever you can think. They keep radiating the signals, right? And I'm here just receiving those signals and connected with the Wi-Fi router. And further, this Wi-Fi router is connected with my ISP. Your case also, it could be any local ISP. In my case, I'm connected with the Airtel connection, right? So this Airtel further connected with a different ISP, different, and it is still going to US where you guys are sitting. And you guys also having a similar kind of the router here, right? They also spreading the signals, right? This is again Wi-Fi, right? And you are also having the laptop. You connected with this Wi-Fi, and we are on the Zoom. So you open Zoom here, I open Zoom here. This Zoom is going to work by the internet. So we are doing the communication within the home. So the setup of your home network is this. So this is your home network setup. This entire area where your router is there, your fire, your router is there, your PC is there. They are known as the small home, right? So this is the small home network. It's like 2 people, 3 people, family member. They are using the internet. So very small, like one router is just going to act as a router. My router is just going to act as a switch because we just provide the wireless connection. No required lot of ports, no money, nothing required. Just after a small investment, I can start using the internet connection and I can start communicating to all over the world, right? So this is known as the your wide area network. Sorry, a small home network, not wide area network. But if we are going to just do the same scenario, let's say suppose you want to open a small office, right? A small office, not the home network, a small office home, similar kind of stuff, where might be not only you, not only your family member, you want to bring, you just want to start your one of the startup companies. So you want to bring your 5 employee and might be 3 family member. So total how many people are there? 8 people are there. So now you required very reliable internet connection, because you have to do some kind of the business, right? So in that case, what you can do, in that case, you still require one of the router. So you can just purchase, or might be you can use the same router, Wi-Fi router, but it is not recommended for any office purpose. So you bring any router from the Cisco, very small one, like 891 is one of the small router, Cisco, and connect one of the switch here. That is again small, and connect all 8 PC on the switch via the LAN cable. This is possible. We can connect because we are total 8 employees, 336 or 7, or might be connect the 8. So they can just simply go and connect to the internet. It's again very small. One switch is going to solve the purpose. One router is going to solve the purpose. Or might be you can connect one of the Wi-Fi. If you want to connect the Wi-Fi, so you connect the AP here, and this AP is going to radiate the signals. And you don't want to connect this via the LAN, you can just set the different PC here. Like 8 user can sit over the Wi-Fi also. So this is also possible. This is absolutely possible, right? So they all get the Wi-Fi signal and they can going to connect over the internet. So the small office enable the computer within the home or remote offices to connect the corporate office. So you can connect the internet, or might be you having the very big office somewhere, you can connect to them as well via the internet. So this is your small office, a small office, home office, whatever you think. Small home is just a home. There's nothing much you have to understand. Okay. So they are talking a small home network, connect few computers each other to the internet. So few computer, little bit more than few, like you have to 8, 10, 20, then you can go with the small office. But when you go for the medium and large, you require the very good network. You require a lot of switches, might be multiple routers for the redundancy purpose, multiple ISPs, right? Because you having the thousand of employees, right? You require the access point, WLCs, lot of network devices is going to be used, right? So might be thousands of network is going to be connected. 2000s of network is going to be devices is going to be connected. So that is the medium and large network where my you can think about any banking sector, too many employee coming. You can think about the any kind of the government organizations, too many employee coming. So they are the very large number of the employee. They keep coming for the daily work. So we require the large number of the network or medium number of network. And if you talk about the worldwide network, this is the internet that is going to connect the millions of the computers, billions of the computers. So this is nothing. This is just internet. So just interconnection of the internet, multiple ISP going to connect together. That's going to become the internet. So if someone is going to ask for the SOHO, so you should know small office, medium office, large office. You should know what that means. Any question? Anything clear? Sagar, all okay?
Yes, sir.
Good. It's very easy. Basically, you guys can understand. It's very easy. Okay, so now the uh, just give me one second. We having a term is the on-premises versus cloud. Okay, on-premises versus cloud. So these are the new term nowadays. People are talking about the cloud infrastructures. People are talking about the on-premises infrastructures, and in between we having the internet. So cloud on-premises. So you can think this is your something known as on-premise, and this is your cloud. So first we have to understand what is the on-premise, right? And what is the cloud? And in between, we just think about the internet. Okay. So what is the meaning of the on-premise? So if I am talking about the on-premise, right? So you think about your office, you think about your home, you think about home network, you think about office network, you think about branch office network. Again, it's like office network. So anything which having the your dedicated infrastructures and you having the network there, that is known as the on-premise, right? So in on-premises, you you could find the router is connected. Behind the router might be dual router is connected. This dual might be connected with the ISP. Behind this router, we having a switch connected here. This is your switch, right? This is your router. And behind this switch, you connected with the laptop, right? Your server is going to be connected. Your printer is going to be connected. Your AP is going to connected. Your any kind of the CCTV is going to be connected. So a lot of devices going to be connected. And now further you connected with the WAN. So now you think about any problem is going to happen in this location, your router stop working. right? Any problem, who manage? Who manage? You, right? AC, air condition devices, who will provide? You. Power, who will provide? You. The office rent, rent of office, who will provide? You. So that means everything inside of this your building that's belong to you and you manage. Everything you provide that's belong to you and you manage that, right? You manage everything. You providing the cost also, right? You providing the cost also. You maintaining the power also. You need to hire the engineer as well. You need to hire engineer to manage them. So engineer also going to require. You have to pay salary for them, right? So everything inside the office you going to manage. So if the situation where you managing everything, that's always that's always known as that's always known as the on premises, right? On premises. Sorry, right? Just give me 1 minute. So if you managing everything, that is basically on premises, right? But let's see, you shifted every network in a somewhere else, right? You shifted the same network somewhere else. This is your router again. This is again another router, right? So this is your router R1, R2, right? This is your switch. This is your switch. So again, this router is going to be connected with the switch. Behind the switch, we having a different, again, same scenario. Different devices connected, right? Like printer connected, like server connected, like Wi-Fi connected. Any network is going to be different connection is going to be happen. Similar kind of stuff. But this is cloud infrastructures. So what is the cloud infrastructures? You just think about that. Two scenario, very simple scenario. You'll understand that. You having a USB drive, right? And you having the Google Drive. What is the difference between these two? So in USB drive, need to purchase, right? Need to purchase. Need to buy whatever you think. You need to take care, need to manage them. It's not, somewhere misplaced, right? You have to pay special care of that, right? Just give an example. Two things you have to do that. You need to buy, you need to take care, like you have to manage. Always need to, put in the safe place. So you have to, safety is your responsibility, right? Safety is your responsibility. Safety, you just have to take care. You just have to take care of the any kind of the management, right? Any kind of the like buy whatever you can think about, right? So everything you just have to basically take care about the your USB drive. Another is Google Drive. What you do here, you store the data by using the store data. You're doing the storing data and you can watch anytime with the help of the computer, right? But if you're using the Google Drive, might be you'll get the free services for a certain period of time, or might be a certain amount of the data, but you just have to pay about the rent every month. If you're just going to use the subscription every month, you just have to pay about the rent. After paying the rent, no need to worry. Where is my USB? Right? No need to worry. It's going to misplace, safety, somebody's going to hack my data, somebody can see. Nothing you have to do. Just you have to pay every month rent and you store your data. Store your data. And whenever you want, you can use it. You use it. That's it. So this is known as the cloud. This is your Google Drive is a cloud-based USB. And this is a non-cloud based USB. Similar stuff is going to happen. Let's suppose your office network here, you have to give the power, cooling, rent for the office, lot of things. But now you not require anything. This device you move in the cloud. Cloud provider, likewise the AWS, like Azure, right? GCP, lot of provider we having in the market nowadays. It is Alibaba or takes Carto, lot of provider available in the market. They are going to just take a rent from you, take a rental, monthly money from you, and they will just manage each and everything. They will provide the power, they will provide the up and working services, everything they are going to provide for you. Everything they are going to provide for you. So you just have to pay rent. You connect your routers, connect your switches, right? Connect your servers, right? Connect your whatever the devices you want to host in the cloud, and you can access them remotely by sitting anywhere. So whatever the offices you have taken for your own infrastructures, and you're just managing them, that you move to the host them in the cloud, and that is going to manage by the remotely, right? That is going to manage by the remotely. No need to worry at all. So this is your PC, and this is going to manage by remotely, right? This is going to manage by remotely. So this is how the cloud. So cloud is something where you just have to pay the rent for the monthly basis, and after paying the rent, you can access them without any problem. Okay. So this is like on premises in the cloud infrastructure. Any question, anything we can discuss on it here, or we are good till now? Okay, so if we are good till here, okay, so what we can do, let me just use one of the small topic, TCP versus UDP, right? So then we'll try to understand these things in the next class. So let's understand what is a TCP and what is a UDP, right? See, if I talk about the TCP and the UDP, so TCP and UDP, because IP addressing and all, I believe we have covered already, right? So we left with here from here. So I'll explain these topics tomorrow, and I'll try to do IPv6 lab. So that's one thing is pending. It's supposed to done yesterday, but somehow I forgot. But no, I'll complete that also. So TCP and UDP, right? So if I talk about the TCP and UDP, so what is the meaning of TCP UDP? So I mentioned in the 𝗧𝗍 model, or like the TCP IP model, we having the different 𝗧𝗍 layers. So in 𝗧𝗍 we having a total 7 layer, right? So we having a 7 layer. So what is the layer? So the first one is the application. Presentation, session, transport, right? Network, data link layer, and just this one is the physical layer. Last one is the physical layer. This is your 𝗧𝗍 model, right? 𝗧𝗍 model we understand about. And we having another model that is a TCP IP model, right? TCP IP model. In this TCP IP model, we having these 3 layer is known as together as a application layer. So we call this all as a application layer. Then after we having a same layer, all we known as the transport layer, and we known as the network layer. Now we known as the data link layer, and this is the physical layer. Right? So if I am talking about the application, right? So application, whatever you seeing in my computer, whatever you're able to see, this is because of the application layer. So application layer is responsible to show you actual output of the programs, data, whatever application you are running. So because of the application layer, you're seeing I'm writing here, you can contain everything is because of the application layer. So this is the application layer in front of you, right? So whatever you're seeing, it is the application because of the application. Network layer, we understand why you use, because if you want to assign the IP, right? Connectivity, right? Connectivity that require the IP. Data link layer, MAC based connection or connectivity. MAC based connectivity, right? Or VLAN based connectivity. Physical layer, your cable. So these three we understand, and this is the actual user display. That is the application. So what is the transport layer? So when you talk about the transport layer, that is responsible for the two protocol that we having the UDP and TCP. We maintain the ports communication, different ports communication. So TCP and UDP is going to work on the transport layer, and TCP stand for transmission control protocol, transmission control protocol. UDP is user datagram protocol. User datagram protocol, right? So these two protocols we have, and these two protocols we having these two sections, right? Right. So now we have to understand what is the TCP and what is the UDP. So first thing, TCP, UDP always going to, right? Always going to work on transport layer. TCP, UDP is always going to work on the transport layer. No need to worry. TCP is known as the connection oriented protocol. So TCP is known as connection oriented protocol. Let me just see here. Website TCP. So see here, you can see here, same thing. Application layer, end user layer, right? So display, whatever you can see here. Presentation session just for just presenting, this is a OSI in your TCP, this is not going to use, right? They're going to combine, but you can see transport, this is a TCP UDP layer, IP, ICMP, IC, they all are going to network layer, data link Ethernet, switch bridge frames, physical is actual connectivity. So session is just maintain the session between the presentations and the transport layer, right? So session is going to maintain. Presentation is going to represent how the application is going to present it on the application layer, right? These are all going to do this way, right? So this layer you just have to remember. You just have to take care about the small things. What are all the layer having a different functionality. But what is the TCP and UDP? So TCP is, as I mentioned, that TCP is just connection oriented. This is connection oriented protocol, and UDP is a connectionless protocol. Connectionless protocol, right? So these two things we can use. There's no problem. We can use these two things. But what is the meaning of connection oriented and connectionless? So if I talk about the connection oriented means, let's say suppose there is two PC, right? There is two PC want to communicate to each other. So while doing the communication, they will do the three-way handshake. See, three-way handshake, they are going to send the sync message. They are going to sync the CNAC message. And finally, your acknowledgement is going to happen. What that means? See, I send one email from my side. So if my receiver receive those email, then they will acknowledge me. Hey, I receive your email. So that is the full proof concept. I receive everything. Likewise, you can think about the couriers. Couriers you sending, you having a guarantee whether the packet has been reached or not, because you having a tracking system. So you can track each and everything in very details. So the courier is going to track each and everything in very details, right? So TCP is something, every information is going to be tracked, but UDP is something you send, right? Something you send, you don't have guarantee it reached or not, might be lost in between. So there is no guarantee. So if lost, it lost. You have to, no idea. You have to again send without any confirmation. But in TCP, if anything you lost, you having a provision, you can do the retransmission, right? So UDP is the, like any voice calls, any video calls, we are talking. These are the all UDP communication. Whatever we are doing is the voice communication. These are the UDP based communication. So that's why UDP is always known as the connectionless, because they don't have any connection to maintain end to end. They don't have acknowledgement system. TCP always known as the connection oriented, because they maintain the connection, maintain the session, right? So if you go in the Google and you try to search your TCP versus UDP, you'll find here a lot of things. So you say TCP is very secure, connection oriented. This is the connectionless, unsecure. It's a very slow because they have to do processing for the three-way handshaking. It's very fast. You having the guarantee transmission, there is no guarantee transmission. If it is going to lost, it is lost. Used by critical application, real-time application, anything real-time. That means we are talking. These are the your UDP, right? Packet recorder mechanism, no packet recorder. Flow control, no flow control. Advanced error checking, basic error checking. 20-byte header, 8-byte header. Acknowledgement mechanism, no acknowledgement. Three-way handshake, no handshake. See, DNS, HTTP, these are the example. This is the, again, for the example. So these all supported by this. So TCP, UDP, you just have to understand like what are the different parameters we have and why we use. Okay. So this you have to understand. So I believe for time being, we can left from here. Okay. Any question, just let me know. Right. I'll try to explain this single mode fiber cabling and stuff tomorrow class, and we'll see what else we left. This I'll try to also explain. Okay. All right. For time being. Okay. We are good.
Good,
Yes,
sir.
sir.
Okay. Bye bye. Take care.
Bye-bye.
Bye bye.